One of the recurring questions we've seen with elimination in the past two videos is this question of which beta proton are we going to eventually abstract to get our product. And if we start with the molecule we have here, we notice that there are two different types of beta protons we're going to consider. The type up here, or I should say the beta protons that are connected to a methyl group, since there will be 6 total and they're all the same. And the ones that are connected to this group over here, we might consider an ethyl group. And there are 2 of them there, but they all function the same purpose. Well, what can happen is we can go through 2 different processes using similar reagents, and let's say we go on the left we're using an E2, and on the right we're using E1. We can go through different processes using similar reagents and get different products. So let's say we're using T-butoxide on the left with E2 and then tert-butyl alcohol on the right with E1. And the only difference between these two is a hydrogen. So if we were to do these, we actually see 2 different products. For E2, with the concerted process, we'd actually see this product as the major product, as opposed to the product for E1, which is actually going to be this product. So what's going on here? Well, in E2, we can actually change the base we use between a sterically hindered base and a non-sterically hindered base to prefer abstracting a certain proton. Perhaps a proton that if we abstracted created a less substituted product versus a proton that would lead to a more substituted product. In this case on the left, we ended up abstracting one of the protons at this location in order to get a double bond like this, a less substituted product. Now, while this is our major product, we also see the minor product, which would be the molecule we see on the right, the product we see on the right. The reason this less substituted product is preferred with the C2 reaction with the sterically hindered tert-butoxide is that it's harder to get to the proton here to abstract it because there's more going on. As for E1, however, we're just going to prefer the more stable alkene, since here we have a tri-substituted alkene versus a di-substituted alkene on the left. Well, why do we prefer this in E1 as opposed to E2? That we're getting similar mechanisms, we're abstracting a proton, correct? Well, one thing to consider is the intermediate with E1. So if I were to imagine going backwards, the predecessor to this was this carbocation. And consider the geometry of this carbocation. Where we have the positive charge, we have an empty p orbital. So this carbon right here is sp2 hybridized, which meaning it's flat. And we have flat molecules, it actually eliminates a lot of the steric effects we're getting, because since everything's in one plane, we're not taking up as much space. And one thing you might notice here, a question that might come to mind is, well, in both cases we had what we might consider a tertiary substrate. If you look at this carbon, it's connected to 4 other things, or 3 atoms not including the leaving group. We might consider it's tertiary. Well, how does that affect E1 versus E2? One thing to consider here is that as opposed to substitution, where we were attacking that certain spot, the substrate, in this case we're abstracting a proton. And the protons are what you might consider kind of the low-hanging fruit because they're extending away from a carbon atom, so it's easier to grab them. The difference between grabbing a proton off of a secondary substrate, primary, tertiary substrate, among those doesn't really matter because they're already hanging out there. The difference doesn't really come to play. So what's one of the key take-home points here is that the E2 mechanism, since it's concerted, gives us an ability to choose which proton we want to abstract and thus choose where we want to place a double bond. As opposed to E1, if we're using that, we're going to get the more substituted product, the Zaitsev product, versus the Hoffman product that we would get for an E2 mechanism using sterically hindered base. Of course, remember, we're not getting just one, we're getting the other one but it's acting as a minor product. So remember, you're always going to get that mixture.